Here's the first video for section 4.8. So a little note about section 4.8 is that we are jumping from section 4.1 to section 4.8. After we do section 4.8, we're going to go back to section 4.2 and then work through the rest of chapter 4. So you might wonder why we're making this decision to rearrange things. I mean, it would be perfectly fine if we went through in the normal, just 4.1, 4.2, 4.3, so on and so forth. But as we're going to see, Newton's method, the topic of section 4.8, is going to be making heavy use of the tangent line, just as we did with linear approximations. So in some sense, our decision to rearrange the topics is justified. So what's going on in Newton's method? Well, I've got a picture drawn here. I've got a picture of the graph of f of x is x to the fifth minus x minus 1. And we want to find some information about this function. And in particular, we want to know, when is this function equal to 0? And if we graph it out, we can see that there's one place at which it's equal to 0. The point that I'm just pointing to right now. If you wanted to do that, we could say, okay, it's continuous, and we can use intermediate value theorem to say, hey, there has to be a root between 1 and 2 by checking values and stuff like that. But we aren't interested right now in arguing that a root exists. We want to try to estimate as good as possible. And as it turns out, we won't go into details, but this is not trying to solve x to the fifth minus x minus 1 is equal to 0. That's not an equation we can algebraically solve using normal high school methods. In fact, in higher level math, you can actually show that there's no quote unquote, nice algebraic solutions to this. So instead, we basically have to resort just to approximating this to as many decimal places as we'd want. And so the method that we're going to learn to approximate roots of equations like this is going to be called Newton's method. And so we'll eventually get to a formula, an algorithm to do it. But before we get to that, I want to do this with pictures. So let's suppose that here is our picture of our function. And let's assume that we're trying to estimate this root, that we're trying to figure out what exactly this value of x is. Or sometimes we might say c here, we want to say, what is c equal to? So here's how Newton's method works. So the first thing is that we need some initial guess. And let's say that right here is our initial guess x naught. We like it to be close to the point, but it doesn't have to necessarily be close to the point. And what we do with our initial guess x naught is that we draw a line up, so we get f of x naught. And then we use our point x naught and f of x naught and information about our function f we compute the derivative of f at x naught. And then why do we do that? Well, we're going to use that information to compute a tangent line approximation. So let me go ahead and do that. We're going to compute our tangent line to our function here. So let me just draw on a straight line. And so what we do is that after we draw this tangent line, we come up with a new guess, x1. So what do? We're trying to figure out when f of x is crossing the x-axis. We have some initial guess. We compute f of x naught. We draw a tangent line to our function f at that point, and we draw that down until it crosses the x-axis. So x naught was our initial guess, which wasn't really too much of a guess, it was just something to get us going. x1 is our first real guess. Now x1 isn't our 0, but we can see we're significantly closer to our 0, our root, than we were before. So what happens next? we compute f of x1, and we'd make another tangent line. So maybe that's what our tangent line looks like. And so at this point now, obviously that's not a perfect tangent line. It's hard to draw a thing exactly right here, but now x2, this is our new guess. We draw the tangent line, we look to see where our tangent line crosses the x-axis. We have a new guess, and then we just keep doing that. We just keep doing this process over and over and over again until we get as close to our root as we want. So at this point, if I draw another tangent line, we basically are there to, markers have some thickness to them. I'm using Sharpie, so it shows up well in the video. You can imagine that if I was being really, really precise with pens and stuff like that, we could be getting even more and more closer to, ever and ever more close to the root that we're trying to find. And so that's the big picture to Newton's method. It's you pick a point, you draw a tangent line, you look to see where the tangent line crosses the axis. That gives you a new point. You draw a new tangent line, you look to see where that new tangent line crosses the axis, that gives you another estimate. You keep doing that over and over and over until you get as close to the root as desired. So let's call that a wrap for this video. In the next video, we'll go from the pictures to actual equations for our algorithm.